Most of the hardware synths today, as well as almost every virtual synthesizer, have an Insert FX section. Now this Insert FX section, as I will show you in Serum and in Massive, serves to give you more control over your sound design. It gives you more options. Now we will go first through all of the effects in Serum and then go through the ones that we have in Massive too. I will shortly explain what each one does. If you want a broader explanation and an in-depth lesson about all of the audio processing, you should check out our audio processing course. Now to start off, let's go in the order that we have them in here. I'm going to initialize this preset, and I will be using just a simple sawtooth to play this off. Without anything, this sawtooth sounds like this. So that's just a simple sawtooth. Now the first one we have is two effects in one. It's called Hyper and Dimension. The Hyper effect, which is added by default once we load it up, is actually this Unison right there. So we have this Unison module. Aside of having that in both of these oscillators, we have that as an effect that we can add up later. So let's hear what that sounds like without and with it. So we go up to 7 unison voices. We can detune, we can rate it up. Since this is not adding unison just like here, it's actually creating copies of the original signal, detuning that, and using this rate, moving that detune slightly. So vibrating those signals that are being copied off of the original. Now we have 7 of those unison voices, and we can also control the mix between the dry signal and the unison signal. So it's just adding copies of the original signal, which is being detuned and then slightly vibrated. Now the next one is the dimension. Dimension effect is also one that we have right here in Massive. Dimension expander, dry wet, and the size knob, just like here. So what it does is actually adding some depth to the sound, making it sound like it's stereo wider, and it actually is because it's introducing latency into one of the channels, left or right, usually the right one. So what it's going to do is if I really crank up the size and add it into the mix, you will hear that latency. So you can actually hear that latency happening because it's really hard. But now when I take it down a bit, make it low and keep the mix. So the latency is just smaller, but I'm still adding the same amount of that effect. So it makes that sawtooth seem much wider by adding an illusion of depth. So we have those two first. Let's turn them off. We have distortion. And this distortion module right here has different types of distortion. Just here, we can add some drive to it. This is how hard we're driving the signal into the distortion, and this is the mix. How much of that distorted signal we are adding to the dry signal. So this is all the way dry, no effect, and all the way distortion, and mix anywhere in between those two. And we have different distortion types. And we also have a custom wave shaper. Now what we can do right there is you see most of these distortions go from a linear aspect into something twisted on this transfer curve. Now what I'm going to do is use this X shaper where I can actually create 2 of my own shaping transition curves, and I'm going to leave the first one linear, but I'm going to change the second one to something really weird, just like that. And now I can, you see, morph between those two. Of course, that shape is actually being copied and mirrored to the first portion because it is symmetrical. So it's a symmetrical shaper. We also have an asymmetrical version of that shaper, which handles that curve and applies it to the entire transfer curve, just like that, from linear into that. See that? Right on the spot. So let's see what that sounds like. so you can create your own custom distortion. You can even do it real time, just like I did right there. Now we have different types of distortions, and what they do is best taken with listening and practicing. Now, an important integral part of this distortion is this filter right here. And you know about filters from the lesson we had already. So this filter can be a low pass, a high pass, a band pass filter, and something in between the high pass and band pass, and low pass and band pass. Since a band pass filter is actually a combination of high pass and low pass, it sits right there in between. Now this filter can be applied before the signal goes into the distortion. So first we apply the filter, then the distortion, or apply the distortion and then the filter. So hence pre and post filtering. So for the pre, we can get some really nice results. So you see, there is a difference if we drive the distortion with a signal that's already being filtered. So hence, you can use this one pre or post, and it gives you a different result. Let's go on to the next effect. Next off, we have a flanger. Now, a flanger is an effect which uses the original signal and adds to the original signal that same signal but slightly modified. How modified? Well, it introduces some latency into that copy and also adds some vibration to that copy, so vibrato to the copy. So when mixed with such a version, the original plus that one that was altered, so a bit of latency introduced plus that vibrato, this is what it sounds like. And of course, we can speed it up. This is your basic flanger effect. We can sync this rate, not to be in hertz, but to actually be an LFO that is synced like a half beat or a whole bar. So it will actually sync to the musical tempo of the project you're working in. So that's flanger in a nutshell for you. Next effect we can go through is actually chorus. And I want to do that because a chorus is really similar to a flanger. The difference between them is that chorus actually adds more latency to that copied version of the original signal that it's adding back. So in this one, specifically, we have two of those delayed signals that we can introduce different latencies for and get a different result. So this is what a chorus sounds like. So without and with. You can hear the difference already. I can add more feedback. I can even filter the added portions of the signal. But this is chorus in a nutshell, so it gives you a more lush, rich sound. A really popular effect that was used widely in the 80s on almost everything. Let's go into a phaser. What a phaser does is really similar to both of these, but instead of delaying the signal and vibrating it, adding vibrato to it, a phaser actually puts the signal that is added to the original through an all-pass filter or a series of all-pass filters, which actually don't filter out any piece of the signal. They actually change the phase of the signal in a certain spectrum position. So in a certain frequency spectrum position, they change the phase, hence you get that notch effect of several notches being introduced to the signal, like the one we saw right here in these special effects, like this phaser filter. And it sounds like a phaser by creating those notches artificially. This is what it sounds like a filter, so emulated. And this is what it sounds like in an actual phaser. Quite similar. So this is the effect we get. We get some of those notches created by the actual shifting of the phase of a spectrum piece of that copied signal being added to the original. Hence, you get all of those attenuations in pieces of the spectrum, and you get that phasing effect. Now we have the delay. Delay effect is really recognizable. It just applies a feedback loop circuit onto the original signal and just repeats it after a certain delay. So in that feedback loop, we have a certain delay and we have certain attenuation. So every next repeating of that signal becomes quieter and quieter and quieter. This is what it sounds like. So that repetition comes from the delay. We can of course change the time of the delay. We can change the mix, how much delay we want to introduce, so dry, no delay, or all delay, no original. Okay, so some specific things beside this delay, we can make it not related to the BPM, so we can actually create a delay in milliseconds. So we can create some really fast delays. Also, we can link those two, left and right, so they always change together. We can make them different. So you see the left one repeats half as often. We can filter the actual repeating that happens. So all of those repeated, except of the original signal, are being filtered using this filter. Like a bandpass filter that we can move around, getting really different results. Another thing we can do is change the mode of this delay. So right now it's a stereo delay, just repeating both left and right channels in a certain time span that we are choosing. So this is the delay happening after every repetition, but we can choose it to be a ping-pong delay. So this way it's gonna happen on one speaker, then on the other, then on one, then on the other. I'm going to choose the same delay time on both, so it gets clearer to you. Listen to that. See that going left, right, left, right, left, right. And we also have a tap delay, which means that the first time we have right here for the left is the time that the delay is going to wait until it starts propagating a delay of this speed, like this. If I introduced a longer time right here, it's just going to wait longer before this delay starts propagating. Let's hear that. So you see, it waits for a whole bar before it actually starts propagating a delay of that speed. Let's go on. I'm going to use reverb next. And reverberation is an effect that gives us an illusion of the sound being in a room of some sort. Now, a hole reverb actually sounds like the sound is in a hole of some kind. We can change the size of that hole and the decay, the length of the reverb, but let's hear it first and then we can play with the parameters. Gives us an illusion of the sound being in a certain room. Now we can change the length of that tail that you just heard, so it can last shorter time. This size parameter changes the size of that virtual room that the sound is being placed in. We can also filter that tail that you heard. We can high cut filter and low cut filter it. We have a spin on it that actually gives it a certain modulation to that tail. And we can of course choose how much we want to hear of the wet or the dry signal, so the original signal or the signal being added to create the illusion of reverberation. Just like that. And we have two different types of reverbs in this module, like a plate reverb. Sounds a bit different because the algorithm for it is different. Now, the reverb can be used and is intended to be used as a tool that creates an illusion of a room, of the sound being placed in a room. So it creates depth for mixing, it creates a larger image of that sound, but you can use a reverb by, let's say, modulating these parameters, because all of the parameters in all these effects are actually able to be modulated by any of the modulators we have. But you can use that reverb, as I've said, as a creative tool, not just a tool to actually give you an illusion of space. We have a compressor next, and the compressor is a dynamic effect. It affects the amplitude of the sound. So how every compressor works is we determine the threshold, we set a threshold for the sound, and if the sound that comes into the compressor surpasses this threshold, it will be attenuated in this ratio of, let's say, 4:1. So whatever passes the threshold of 15 dB, if the sound is louder than minus 15 dB in digital full scale, it will be attenuated 4 times. So that part of the audio going over the threshold, being louder than this line that we set, is going to be 4 times less loud, or 5 times less loud, or 6, 7, 8, 10, maybe even limitlessly, so infinite to 1. That's what the ratio is. 2:1 means that the resulting signal going over the threshold is going to be twice as low in volume than what it originally is that goes over the threshold. And we have even finer settings for that. And we also have really extreme settings like a limiter, which is actually infinite to 1. Let's hear what that sounds like. Now, what you can see right here is a gain reduction meter. It shows us how much gain reduction we are applying with this compressor. It shows us how much volume of the sound, the gain, is being reduced to actually satisfy all of the parameters we have set in the compressor. Now, we also have this attack and release parameters. The attack parameter and the release parameter are all time-based. You see in milliseconds. And they give us a certain control over the reaction of the compressor. So the attack time tells us how much time it takes for the compressor to start compressing in this ratio from the time when the signal passes the threshold. So the signal passes the threshold, and the compressor will take 816 milliseconds to get to this ratio. Or it can be faster, it can react much faster. Also, we have a release setting, so that when the signal goes under the threshold and does not need to be reduced anymore in gain, the compressor can stop gain reducing, and it's going to take this much time that we set right here. So this is how fast it starts compressing after a signal has passed the threshold, and this is how fast it stops compressing after a signal has passed under the threshold. The gain is just a makeup gain that we use after all of this processing to boost up the volume. Once all of the gain has been taken out, we can use this to compensate back. Now, this compressor can be a multiband compressor. Now, what that means is that once the signal enters this compressor, it will be split into 3 bands of frequencies. Frequencies that are low, mid frequencies, and high frequencies, and all of those 3 will be compressed separately. Another special thing about this multiband compressor is that it's modeled after a really popular compressor being used today called OTT. And this compressor has the downward compression like the normal one I just showed you, separated into bands, but it also has upward compression that is served to actually boost up the signal that is under the threshold. So it will effectively try to keep the signal's balance within this black area right here. Let's hear that. So it's boosting this high frequency. Now if I pull it down, it will be compressing it. So I can effectively control the spectrum balance of the sound by just moving these thresholds up and down. Now this can help you immensely in controlling the spectrum balance of a sound using a multiband compressor just like this one. Now we also have an EQ, and I've told you in the filters lesson what an EQ actually is. It's a collection of filters. This EQ has 2 variable filters, these 2. They can either be cut filters, peak filters, or shelf filters. Now, the shelf filters are the ones that we did not mention in the filters lesson, because they are usually used in equalizers. What are those? Well, this is a low shelf filter and this is a high shelf filter. A low shelf filter actually alters all the frequencies below the central point we choose. So everything below 1058 Hz is going to be boosted or attenuated, just like this. And the Q setting will help us determine how fast that change is going to be from the point where we start actually altering those frequencies. It can be really mild, just like that. So this is the shelf filter. Let's try that out. Okay, boosting or attenuating all of those frequencies. Or we can use a high shelf filter, which is the same thing, but it attenuates or boosts all of the frequencies above this central point that we choose. So not below, but above. That's why it's a high shelf filter. It alters high frequencies, higher than this point. We also have the Q control. We also have the gain control, which can attenuate or boost. Let's try that out. And we can, of course, make both of these into peak filters, just like that, where we can control the bandwidth of the filter, the frequency, and the gain. So they can actually gain or attenuate certain frequencies, the band of frequencies that we chosen. We also can turn these into cut filters. So this one would be, the one on the right is going to be a high cut filter or a low pass filter. If you remember, they have two definitions. It's cutting the high frequencies or, in the same sense, letting the low frequencies pass. So we have a high cut filter or a low cut filter. A low cut or a high pass, in the same logic, that it's cutting the low frequencies and letting the high frequencies pass. The last module we have right here is a filter. This filter is identical to the filter we have right here in the main panel of Serum. So it has all of the same filters that we can choose, has all of the same controls that I already showed you for this filter, also has the drive, the fad, the panning, and it has the mix. So we can apply that filter with some strength in regards to the dry signal, so we can mix the filtered signal in with the original dry signal, dry or wet, just like that. Now let's go into Massive and see what kinds of effects Massive has. Now the routing in Massive is quite more complex than routing in Serum, but we will get to that in the next lesson. For now, let's get through all of the effects it has. Now we have 3 of these, 2 effect slots and an EQ that are always in the path if they are activated, just like this, just before the master output. So after all of these filters and everything else, we have these FX slots, these 2, and then an EQ, and then the master output. For the first one and the second one, we can choose different effects that are going to populate the first FX slot, second one, and then the EQ is always fixed. Let's see what the EQ has. The EQ has a fixed low shelf where we cannot choose the frequency where we want the low shelf to start, or a high shelf frequency we want it to start from. We can just alter the gain of the high shelf, low shelf, and for the middle one, we have a peak filter, which can boost or attenuate a certain frequency, like this. We cannot choose the width of that frequency band, but we can choose to boost or attenuate it, and choose the center frequency for the band. We have 2 FX slots, which can be populated by reverbs, flangers, chorus, phaser, delay, dimension expander that you also saw in Serum, and a few tube distortion types. Also in the second one, we have all the same of those, we just don't have all of those distortions. Let's hear what they sound like, just a tiny bit, because they are supposed to be similar to the ones we have in Serum. Just like that, you can hear that this simple, let's say a sawtooth, being massively changed, as you can hear. And that shows you that the effects are a really important tool of sound design. Now, aside of all of these, and you know all of these effects, we already have them in Serum, and I show you what each one does. Besides all of those, and the EQ that are always last in the chain, what we also have are two insert slots that we can actually insert somewhere in the signal path. I told you already that Massive really has a more complex routing scheme than Serum, and we can insert one of these two somewhere in that routing scheme right there. So what I'm going to do is just show you, because these both have the same effects, I'm going to show you what they can actually encompass, what effects they have for these two that we can change the position of. We can put them before the filter, when going from filter 1 into filter 2, after filter 1, before filter 2, after filter 2, after both of those filters, in the feedback loop, which we will talk about in the routing lesson. So we can actually use them right there. I'm going to put this insert 1 after all of the filters, which are, of course, non-active, but just so we can hear the sawtooth through these effects. We have a simple delay that just creates some delay added to the signal. We also have a sample and hold effect, which is more like a sample rate frequency degradation. So we are actually reducing the resolution, the frequency component of the resolution of our sound, degrading the sound. We can also use a bit crusher to degrade the amplitude information of our sound, making the sound not 16-bit, but maybe even 8-bit, just like this. We have so many creative effects right here, like a frequency shifter, a high pass and a low pass filter in one module. So and that's really handy. We have a sine shaper. It's like a distortion, like the one you saw in Serum. We also have a parabolic shaper, different kind of transformation curve that you saw. And we have a hard clipper, also a type of distortion. And all of these actually do depend, especially the clip one, on the strength of the input signal into this module. So you see, it changes the sound drastically. Now, those are all of the effects that you have, and you can see that you can modulate the parameters of all of these effects right here, as well as the ones in Serum. So I can use an LFO to modulate any of these parameters in these effects, in any of these effects, just like that. So I can do the same thing right here in Massive. I can modulate the parameters right here and right there. You see these boxes, so you can add any of the modulators right there and make them modulate the parameters of the effects. This gives you a lot of variation to any sound you can make, gives you a lot of flexibility, and these effects actually are a really important sound design tool when you use them creatively. Now, once again, if you want to know much more in depth about all of these audio processing effects, check out our audio processing course.